Alright, so let's get into details on how to guess YP correctly. So there's going to be two rules. This is for guessing YP. So rule number one says that YP, your guess, must include all the terms in all the derivatives of f of x. So here's the chart. If your f of x is a polynomial of degree 3, then the derivative of polynomial of degree 3 contains terms x cubed, x squared, x, and constant term. So a correct guess will be ax cubed plus bx squared plus cx plus d. Now if your f of x is, let's say, a trig function, sine of 2x, you have to include not just sine of 2x, but also its derivative. So we also have to include cosine 2x. And if your f of x is a polynomial times an exponential function, then aside from the original term, we need to include all the terms in the derivative, which is x times e to the negative x and e to the negative x. And the same applies to if you have a polynomial multiplied by a trig function. Then in this case, you have to include x cosine 3x and x sine 3x and their derivatives. So be c times cosine 3x and d times sine 3x. Alright, so that's rule number one. And the rule number two says that YP must not contain terms appear in the complementary solution YC. If this happens, it does contain, then we need to multiply the original guess by a power of x so that it does not contain. So let's do an example here. So let's consider the differential equation y triple prime minus y double prime equals to x squared. The homogeneous part is y triple prime minus y double prime equal to 0, which leads to the characteristic equation r cubed minus r squared equal to 0. So r squared times r minus 1 equal to 0. So the roots are 0 and 1, and 0 has multiplicity 2. So the complementary solution looks like c1 times e to the 0x plus c2 times x times e to the 0x because it has multiplicity 2 plus c3 times e to the 1 times x. E to the 0x is 1. So the complementary solution looks like c1 plus c2x plus c3 times e to the x. Now we want to guess our particular solution. So if we look at the right hand side, then our original guess is YP is a polynomial of degree 2. So the original guess is YP equals to ax squared plus bx plus c. But notice that these two terms are duplicated in the complementary solution. And we don't want that. So to avoid duplicates to happen, we have to multiply it. X squared to avoid this happen. So the new guess is YP equals to ax to the fourth plus bx cubed plus cx squared. Now there's no duplicates. Yep. And we can use this to solve for A, B, and C. We're not going to do this again. All right, so let's do a different example. So let's consider the equation y double prime plus 4y equals to 3x cosine 2x. So the complementary part is y double prime plus 4y equal to 0. The characteristic equation gives you r squared plus 4 equal to 0, which means r squared is negative 4. So r is plus minus square root of 4, which is plus minus 2i. So the complementary solution is the linear combination of cosine 2x and sine 2x. Now we want to guess our particular solution. So the right-hand side is 3x times cosine 2x. So our original guess is yp equals to a times x cosine 2x plus b times x times sine 2x, and their derivatives, so plus c times cosine 2x plus d times sine 2x. But notice that they're duplicates. These two terms appear in complementary solution, so these are duplicates. And we cannot let it happen, so what we do instead is we multiply this by x. So the new guess is yp equals to ax squared cosine 2x plus bx squared times sine 2x plus cx times cosine 2x plus dx times sine 2x. All right.